So we're on box 16 today. The audio line can go back to the customer, and so we're on box 16. Now I've put this in our normal repair system so that it was in a specific order, but this has been sent to me as a free gift. So it is a repair, but it's a repair for me. And I think it's come from the same person who kindly sent the Falcon little dinky set. And this is amazing because we did that Maxcom 4E last week, which we couldn't charge for because we couldn't get it up to spec. And then the very next day we did a Commtron 40, and it really looked shabby and the mic was duff, but it came out, it really worked well when it was serviced. Put a new mic to it, and that went back. So imagine my surprise when this arrived, and he's a Commtron 40. So he sent that well before he knew we'd been doing a Commtron 40. Fussies. Don't know. So we'll sort that power lead out because we've got new ones available. Yeah. Which we sell via eBay. Will this be the odd mic that still works? So let's see what he says. Nice to see you fixed the Falcon CB. Here's another for you to work your magic on. I resprayed the case, made a crude power lead, and cleaned the switches with Servisolve. Fault does not transmit, meter does not move, TX light does not light. It looks like someone has been in it before. I put a dot of Tipex on the chassis where the parts have been touched. So once again, thank you very much indeed. It's really appreciated. So we'll connect this up to our power supply. I won't bother going through the rigmarole which we normally would have, running it at a lower voltage and a lower current, because we know that it already works. We'll plug the supplied microphone in and switch on the power supply. So 13.8 volts, 1.6 amps available. Quick press into transmit, nothing happening. So first of all, we'll switch it into PA mode. Testing 1 2, testing 1 2. 1 2 1 2. Surprise, surprise, there's no transmitted audio because, as ever, the insert will be knackered in the microphone. Somebody's put me onto farnell supplying replacement inserts which you can make fit. So that's good news. So to get it into to actually transmitting key up, we'll use this mic for now. Then I'll make another mic up if and when we get to a stage where it's working. So plug the instruments in. We know it doesn't transmit, and so what we'll do, we'll put 2779125 into the signal generator. And we can hear it's receiving that. Scissors can go back to the kitchen. Right, so have a look at that SINAD meter. So switch picture in picture on, and we'll go to the SINAD meter if we can actually line it up. Let's see how it's receiving. So a 12 dB SINAD is doing 2.2 microvolts. Needs to be under 1, so that's not acceptable. Right. We'll open it up. I'm going to have to take all the lids off. But just for this second, we'll unscrew the bottom lid. There we go. So it's not a high hours set, and it's not been damp. Look how shiny the chassis is, bearing in mind it's 40 years old. October 1981, so it's one of the very first production. Has a 2SC2078 fitted, which is will be the factory original. So here's the little test. Get our handy walkie-talkie and see whether it's transmitting 3 inches. Testing 1, 2. And yes, it's transmitting 3 inches. So we've either got output transistor or driver transistor faulty. So now we'll take the other screws out. So the chances are that if it's a bad output transistor, then it's been on a bad aerial. You know what? It's not been touched. This. Good. See if the meter works. Can't see the meter working. Low power, high power, just checking that it isn't simply the switch. So we'll get the RF voltmeter out on the highest scale it's got. Put the handle to one side, we know it's generating the frequencies. So we know that this is the output transistor. So it looks to me like the output transistor has been killed. Here's the driver transistor. So you can see we've got a lower input there. Well, you would if you put the meter in the shot. So on the driver transistor, the lower input's there. The output is there, which goes into the output transistor there, and then coming out of the thing we've got next to nothing. So if I put that on the socket, next to nothing. It's just enough to, if I put this in the test set in the 3 watt range, 27.7, it's just transmitting So we're just going to make sure that things look like I'll just see what the current is. It's drawing 420 milliamps. Well, I think we're going to be straight in with the output transistor here. So just check very quickly. Peak, 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 I'm just looking for his tip X marks, but I haven't spotted any. Alright, we'll take the transistor out, switch the power off. I've just had a delivery of these today. They're probably fake. And then we'll be back to square one. So remember, you've got a insulating bush and a mica washer, because the tab is isolated from the chassis on these. Right, we'll just unsolder that. Okay, so we've got a clue here that in fact it's 2092 that's come out. It should be 2078. We'll look that up later. That's Hitachi. That can't have been original. So let's see whether we've got a transmit now. Wow, yes, 3 watts. So now we know we've got 3 watts. Let's see whether we can get 4 out of it. About 3.5. And then you're supposed to set, if you've got more than 4 watts, you're supposed to set it with this one. And there's our 4 watts. So just check that we've got this one right, because some of it is interactive. Yeah. So there we are, full 4 watts. So when we look at the spectrum analyzer, if I just key up, it's all over the place. Right, so we just need to see why that is. And that final coil one of these. I think it's that one there. I think it's dry joint. Right, we'll put the camera back to its normal position. And we'll see whether we've got rid of... I better switch the radio back on. Just put the bottom lid back on because it's not ideal without. Right folks, we're down to one trace. Got rid of the dry joint. That's what it was. I've just gone under these coils. I don't usually get dry joints on these, especially when they're in such good internal condition as this one is. But there you are, it's done it. Let's go back to the normal test meter. Let's go back to the normal test meter. And we've got a full 4 watts. So let's go to low power. See what we've got now. 100 milliwatts. So without getting the bump out, I think it's that one. $400 milliwatts it is. Oh no, I'm on the wrong scale. Silly me. That's 4 watts. So there we go, 400 milliwatts. And then on high power, the full 4 watts. Can't do deviation until we make a mic up. So we'll now look at the power going on the RF meter. It's reading between 4 and 5. So we'll just pop that down a bit. It's one of these presets, isn't it? Well, that's interesting because the meter wasn't working, it isn't again. Now, I wonder what made that start working then stop again. Is it a wire on the meter? Is it internal? Well, it starts to work again now I've poked at the wiring. So we'll just set that preset. Just wants a bit of service cell on it. There we go, that now reads the 4, which is what we want. That's a bit generous, it's just over. Good, so that's that set. Can't do deviation as I said. So it's the S meter now reading. It is. So I wonder if we can replicate the fault by poking at the wiring on the back of the meter. I'll just do a bit of solder on those 2 wires. They don't look dry joint. Well, that seems stable now. I didn't expect that. So we know we've got transmitted audio to do, but we will now do receive. So one of the things this chassis suffers from is the detector going out. Before we move on to that, I suppose we ought to put the oscilloscope on. There we go. Turn the bench light off. Let's see whether we can get anything more out of the detector, which is the coil down here. 100 microvolts on the signal generator. Enough volume to see a trace on the oscilloscope. That needed a bit of adjustment, so it's done. Bench light back on, oscilloscope off, over to the SINAD meter. Just quickly run through this and see whether we can improve the 2 point something microvolts it's doing. So we've certainly got 4 dB by putting a 1 microvolt signal on. So that's made a big difference. That's made a big difference. That's made a difference. I'll just turn this down now. You know what, my test set doesn't sound like we've got the right amount of audio on it. It's supposed to be 1.4 kilohertz of deviation. Let's just see where it is. Let's go back to the main meter. Let that drop off. No, I don't get that. Right, so that's gone through it a couple of times. Let's see what we've got on the SINAD meter now. See whether it's acceptable. No, it's not. It's 1.3 microvolts. So I'll look into why that possibly could be. So we're in one of those situations where this radio isn't good enough. So I've sorted the transmitter out, but the receiver is just that bit too deaf. Let's see where we now are. About 1.4 microvolts, so it was 2.2, so retunes brought it up. So I've printed off a squirkit diagram. The signal comes in here from the aerial. So what could play up? Well, the transistor there could be low gain. The diodes there could be leaky. that electrolytic capacitor, and these aren't prone to electrolytic capacitor snags, it's right on the base of that transistor. So if that was at all leaky, it would be shunting part of the signal to ground. So that electrolytic capacitor, again, that could be shunting it to ground. So I think the first thing to do is to change those two electrolytic capacitors. And it's certainly the cheapest thing to do before we start testing transistors and that for gain. This would work, you know, we'd get to scratchy corner, we'd be able to hear him, but it wouldn't be good enough. So I'm glad I did a really good scan of the instruction book for the other Commtron that came in, because I was able to find capacitor 234 just there and capacitor 106 just there. So 4.7 microfarads and 10 microfarads. So I've changed those, and I think we'll just test. And Mr. Chippy's just said, where is my semiconductor analyzer off his bench? Oh, hello, Mr. Chippy. He stood there. Right, I'll just test these, and then I'm going to disappear and see Mr. Chippy. We'll just check this, see what it says. Well, that says it works. Certainly not putting them back after 40 years. And that says it doesn't work. So we've changed them. Plug the mic back in so we can actually hear something. And just see whether we can tune better. Still got to go through it because it will have changed the tuning. We don't have to go through all of them because it's not going to affect all of them. Okay, let's get the reading now. .4 microvolts, so no real improvement. So we're going to have to move to transistors. So we'll start with the first one, which is the MPS 9426. So I look up the first transistor, MPS 9426B, in Towers International, and it's not listed. So what we'll do is we'll recover something out of this scrap set. And as it happens, they're all the same device number. Okay, so I had to go and answer the phone and take the picture off. Oh, I pressed the wrong button. I'm trying to think what I've caused now. Right, so we've taken the one out of the radio, and let's see what the gain is. We do have other equivalents books. We've got some of the ECA Japanese books. And as long as you can match the symbols up for base emitter and collector from Japanese to English, then your quid's in. So this is what's been in the set, and it's got a gain of 85. Okay. So this transistor is going to be susceptible to being damaged by things happening aerial wise, and remember this set's had dry joints, which I think have caused the output transistor to fail rather than the bad aerial with hindsight. So let's see what this one says. This has a gain of 90. So we'll put the one in out of the scrap set. Anything which will bring this under 1 microvolt, and that's all we need to do. We've done the capacitors, and one of them was faulty. There's no denying that. All we've got to do is to try and put this back in. And while I faff around with tweezers and things, we'll pause the video. Right, so we'll try again. Now that is actually showing better on the SINAD meter. Let's put this, it's still on, isn't it? So we may have cracked it. So we'll just go through the tuning again. Put it to 4. Just trim the frequency on the test set. Just check the radio's still on frequency. It is, it's spot on. Right, let's get a new reading. .3 microvolts, so it's not good enough. So we've gone from 1.5, changed the capacitors, 1.4, changed the transistor, 1.3. So if everything can make a tiny bit of difference, because we've got a tiny bit out of spec, then this is what we're doing. So transistor 101 is next, Q101. Let's find Q101. And so we've done Q104, and Q101 is next. Q101 is there between the two cans. So that's our next one. So once again, this is the one which has come out of the set. $116 is the gain on that one. And this is the one off the scrap set. Or is it the other way round? $135. So again, once again we've got a little bit more gain on that one. So we'll put that one in. Okay, so once again, put that back on. And the phone's ringing. So just as a reference, I've just plugged our handheld in, and the 12 decibel SINAD, which we've now got there, this handheld is doing 0.48 microvolts. So without moving the attenuator on the test equipment, I'll just take that adapter off because that's TNC. Put that back in. So we haven't changed it at all, as you saw. So we'll now have to move the attenuator from 0.48 to the next scale. So now what we're going to do is just going to tune it once again, having changed that transistor. Let's see what we've got now. We've actually got 1.15 now microvolts. So again, it's come up 0.1. So if everything has lost gain by just that little tiny bit, you can see how we've come. We did the retune because it was 2.2. That brought it to 1.5. And then part by part, we managed to get it to 1.15. So the next thing to do is I'll change. Well, I may as well change them both. So that's what we'll do. So transistor 102, which I've just taken out of the set. 108 is the gain. A replacement for transistor 102. Is 82. I'm not going to put that in, that's worse. Replacement for 103. Sorry, original for 103. Is 104 again. And the replacement I've got in mind $80. I'm not going to put either of those in. I think we've just found why the set was scrapped. Right, we'll find something else. So, looking it up online, BF255 is a European equivalent. And I have two in stock. Signetics in an unbranded one. So let's see what we get. And let's take notice of the pinout. And this has got the very dirty leads that causes dry joints, so if we fit this we'll be cleaning it. I've had this in stock since the 90s. Yeah, so we've got a gain of 119, which is excellent. And it's actually labelled collector emitter base. So blue is collector, as it says, red is emitter, which it is, and green is base. So looking at the diagram, does that figure? So collector emitter base. Right, folks, it's the opposite way around, isn't it? No, it's not. No, it is. It's the opposite way around. So collector emitter base on this. If you've got it looking like a D, this actually needs to go in like that. So these are things to watch. So we'll just put this in seemingly wrongly. We'll just clean that up. I'll pause the video. So the second transistor we'll put in. Of course, we've no idea whether this is the same pinout as the first, hence using a tester that tells me the pinout. No, not good enough, is it? Not good enough. So emitter is red. Blue was base. Yeah, it's the same pinout as the last, but it's not a good enough example of the device. Okay, so we've got one in. Now we'll have to find another from somewhere. So the next one we've found in a scrap Colt 355, which is a shame because it's quite a rare set. It's already smashed to smithereens when I bought it. It's an MPS 9426. 139. That's spiffing, old bean. Well, if these two don't fix it, at least this one will go in the right way around. Right, we're going to have to leave it at 1.1 microvolts. We could change the filters. There's two of them. We could change the transistors in the 10.7 and the 455, and so on. We're going to do a scratchy corner test. This is now more sensitive than those, you know, those really squish-looking Cobra 29s, which only just aren't a current model, which are pretty dire. And some people swear by them, but it's about sensitive as one of those. Right, so we need to. Mr. Chippy's doing a mic for this as we carry on with it. And so what we're going to do is set the S meter. So on S9 on the test set, 100 microvolts. It nearly is 9, and if it's adjustable, then there's a preset on the back of the meter. If. And it isn't adjustable on this model. This is an early one, you know. So the meter is what you'd call very slightly lazy, but then seeing as the hole receives very slightly lazy, it's actually 300 microvolts for S9. So back to the normal plan, and we've done our RF meter. We can't do deviation until the mic turns up. There's the squelch. There's the squelch. Hang on a minute. What's this then, folks? This isn't shown on the squirky diagram. Is this? You know what? That's S meter. Well, I've never seen that before, but I say it's early production. So at full chat, we're about where we want it to be. It's very, very slightly lazy, and to give an accurate thingy, it is 150 microvolts. So there we go. It'll read plus 30 when we want it to. Good. So we just need to do the squelch. So we're just going to turn the signal generator down, turn the squelch to full, turn the signal generator back up to 100 microvolts, 3, 10, 30. It's coming in too early, so it's going to be this preset. I want a bit more off than that. Needs to come in at that point. Yep, that's it, 100 microvolts. Excellent. So now we'll see where the sensitivity is. So, signal generator to standby. Right, squelch to the threshold. Switch the signal generator back on. It's parked at 0.3 microvolts. Just about came in at that. So it's coming in at 0.65 of a microvolt, and it's leaving at 0.5. Just about. So sensitivity is there on the squelch. So I just need to change. I just need to change the transmit LED, which will have failed. and these are fun. Okay, so just to finish off, I just need to put the lids on. We've done the LED, they're a swine to get to, and just pop these screws in, never over tighten these. We'll see how it performs on a scratchy corner test. Put the lid on the right way. Make sure we're not plugging the extension speaker in. So basically what's happened is that the transmitters had dry joints, just a couple on coils, just because of dirty leads when it was assembled, and that will be what's caused the output transistor to fail, and I think it's taken its toll on the receiver, all the spikes that's generated. When you saw on my spectrum analyzer, and for some reason it's got not the output transistor I was expecting. I don't know whether we discussed that, but it's supposed to be 2SC2078 and it was 2SC2092 from Hitachi. So I don't know. I'm not going to put any screws in right now because I want to battle on with it on the air test. Mr. Chippy's done the microphone. Oh, you know what? We've not done the deviation, have we? What a plonker. That'd have been funny, wouldn't it? If you couldn't hear me, or I was booming out. Right, so we've done a brand new microphone. Switch the power supply back on. Oh, we're in PA, aren't we? It's banging out. He's put that screw in too tightly, as Mr. Chippy. Right, deviation. Let's look at the meter. Wallow, 1, 2, wallow. It's a little bit too high. One, two, wallow. That's too low. Wallow, 1, 2. That's it. So we'll leave it with no screws. We'll come back to that. I've got a radio net, so I'm just trying to get through with this. So we'll do our usual thing. We'll plug the roof aerial here, and I doubt it's going to hear anybody in Nottingham, with it not being quite as sensitive as it ought to be. Well,
I don't know who she's been with. She could have been with Elroy's about me. I can't see anything comes up here right now. It's wide open. That's right, that's your... I can't tell this. What is wide open? Radio 2, and this accuracy is very, very...
oh, sounds like the burner brigade are on from abroad. Right, well, there was no point going 1-9 Roger with all that rabbit and rabble about various dodgy people and what they're up to. What they're effing up to. Yeah, got to get it right, Mr. 21. What they're effing up to. Right, well, there we go. So thanks for watching the Commtron CB40F, which is amazing because we've had two so rapidly. We've actually heard somebody talking on it, which this is a dev set by my standards, not by Cobra 29 standards, and we're going to do an on-the-air test immediately. So thanks for watching, and thanks so much to the person who sent it. We'll be able to get an insert for that mic with that little bit of knowledge that I've been given during the course of the week.